Skill 2 in Chapter 11 deals with phase changes, more specifically reading and interpreting those phase changes and the intermolecular forces using graphs. So I want to go ahead and show you an example of breaking intermolecular forces to go through phase changes, and then we're going to look at a specific type of graph you want you to be familiar with. So you can see right here we have two compounds. One has weak intermolecular forces and one has strong intermolecular forces. And this is the trend of them going from solids to liquids to gases. Now you can see the one on the right with strong intermolecular forces takes a lot more energy to break those bonds to make it go from solid to a liquid. Because the intermolecular forces are so strong in holding it together, you need a lot more heat to break the bonds up and cause it to turn into a liquid. The same is true from going from a liquid to a gas. Now, the weaker intermolecular force compound is going to do the same thing. It's going to go solid to liquid to gas. It just doesn't require as much energy to do that. A lot of times we might see this drawn as a heating curve. Just quickly, a heating curve looks like this, where we usually start off with a solid and then a phase change, then a liquid, then a phase change, then a gas. But it always has this stair-step look. So I'm going to flip a few pages, and this phase diagram is for water. I'm going to show you a few points on this diagram, and it'll be true for whatever compound he decides to throw your way. So we'll always have our solid over here on the left, our liquid in the middle portion right here, and our gas underneath this curve, right? So you can see right here we have a triple point, and that's where the substance, in this case water, can exist as solid, liquid, and gas. And it has to be at whatever pressure this is and whatever temperature this is, right? If you go onto this graph and you find wherever the pressure is equivalent to 1 atm and the temperature is equivalent to 0 degrees Celsius, or STP, right? This is going to be called our normal melting point. So 1 atm, 0 Celsius. Our normal boiling point will be at 1 atm and 100 degrees Celsius. And the reason it's 0 and 100 is because we're dealing with water. And the last point that he might ask you about is called the critical point. So it'll be wherever the gas and liquid phases meet, all the way over here at the very end. And you cannot liquefy by compression alone, right here. This is at the critical point. So if I were to go from solid to liquid this way, right, that would be melting. Liquid to solid, that would be freezing. So he can ask you about all these phase temperatures between solid, liquids, and gases, and you just have to look and see where they're touching. So on this point in the line, liquids and gases are both touching it. This point in the line, solids and liquids are both touching it. So we're going to start answering some questions using a graph that looks like this. So there's just another one on the next page, but this time you can see the temperature's a little bit different. And that's because we're dealing with CO2 and not water. Right? Oh, here's the heating curve I was talking about earlier. So this is where we would have solid, phase change, liquid, phase change, gas. If you read it backwards, we have gas, a phase change into a liquid, a phase change into a solid. And this is going to be used a lot in 1202. It's an easy graph to read and understand, so just be familiar with it. Okay, so let's go ahead and try some problems out, Skill 2, Chapter 11.